Welcome back, and thank you very much for staying with us. We hope you guys are still enjoying the show, but above all, we're hoping that you are learning a lot from our program. Remember, this week is the week for first principle, and we are just doing the last touch-ups on differentiation by first principle. From next week, we are continuing with differential calculus, so you can start sending us any questions that you might have that are based on cubic graphs or optimization. We will be more than glad to look at them and help you to make sense of those contents. Now, we are now going to go to a question that was sent to us by Simone. Let's go and check out that question.
Hey Tenfold, my name is Simone and I have a problem with this mathematical question. Please help me.
Okay, thank you for that question. It is actually a great question. Thank you very much for that. It is important for you to understand that the question of first principle is always asked. You cannot run away from it. There are other techniques that you can apply to find a derivative, but the first principle will always be one of the questions that you're going to get, and it's usually around 5 marks or so. So it's important for you to understand how to apply yourself when you are doing differentiation from first principles. Now, the question that Simone sent to us is asking us to find the derivative from first principle. Let's go and check out what the question really looks like. It says, find the derivative of f of x equals minus 4x minus 7 into x plus 2 using first principles. So the key word here is the word first principle. If we just asked you to find the derivative, you could have used any other technique that works for finding derivatives. But we have to find the derivative using first principles. So once you see the word first principles, you must know that we are going to apply that little formula that is available in a formula sheet that says the derivative is equal to the limit, right, as h approaches 0 of f of x plus h minus f at x, everything divided by h. So this is the formula that we're going to use. Now, this formula has two parts on the numerator that we need to work with. The first part is f of x plus h. The second part is f of x. So more often than not, it becomes easier when you work out f of x plus h and then substitute into the formula. Once you do that, it becomes easier for you to simplify the question, because some people prefer substituting everything into the formula and doing simplifications there. I find it too complicated. So I prefer to work out my f of x plus h first and then take it and substitute into the formula that we are using for finding the derivative. So let's go and check what is happening here. I was given f of x. So I'm going to first of all say f of x, right, before we go to x plus h equals negative, open bracket, we've got 4x there, minus 7, close bracket, into x plus 2. So we need to have, for our formula, f add x plus h. And this basically simply means wherever we see x, we are going to substitute it with x plus h. So let's try and work out what the value of this is going to be. So this is going to be f of x plus h, which is equals to, there's a minus, I'm going to rewrite that. There's a bracket, allow me to put a square bracket. There's a 4. I'm putting that as well. There's an x now. Everywhere where I see x, I'm just going to sub it with x plus h. Close brackets. There's a minus 7. There's my minus 7. And then a closing bracket there. In the second bracket, we also have another x. We said every time you see x, just put it as x plus h. Close bracket. And then we've got a plus 2. Right, we've just found our f of x plus h. Let's try and simplify this. It's going to be negative. Now, if you work with what is inside the bracket, you will basically sit with 4x. And when you multiply 4 and h, it's going to give you 4h minus 7, close brackets, into. Now, on the second bracket, I already have x plus h plus 2, which is basically going to be x plus h plus 2. Right. If you simplify this further, what will happen is you'll have negative. Okay, fine. You will notice that we don't have any like terms in the first bracket. We also don't have any like terms in the second bracket. So if you may allow me, I'm just going to start doing the foiling. Multiplication there. This will give us 4x squared. 4x times h will give us positive 4xh. And then 4x times 2 at the end there will give us positive 8x. Now we're going to go to the second term, which is the multiplication by 4h. 4h times x is going to also give us positive 4xh, and then 4h times h will give us positive 4h squared. And when you multiply 4h times 2, you're basically going to end up with positive 8h. Now the last multiplication is going to be multiplication by 7. So 7 into x is going to be minus 7x, and then minus 7 times h will give us minus 7h. Minus 7 times 2 is going to give us minus 14. Let's try and fix that by simplifying. The first part there, 4x squared, does not have a friend, so we are going to put it down as 4x squared again. Let's look if we do have any like terms here. I see we've got 4xh there. We also have another one there, which is 4xh. So we've got actually 2 of them in total. So when you add them, they will basically give you positive 8xh. And then let's check the x's. If I look closely, I can see that we've got 8x there, who is friends with minus 7x there. 8x minus 7x is going to give us plus 1x. And then if you look closely, we also have h's. There's 8h right there at the end. There's 8h there with minus 7h. When you add those two, you'll basically have 1h. And then the constants, the only constant I have here is minus 14, which doesn't have a friend, so I'm going to rewrite it as minus 14. And then from here, we need to simplify further by multiplication with this negative. Negative inside, you get minus 4x squared. Negative inside is going to give you minus 8xh, and then negative is going to give you minus x, and then minus h, negative and negative at the end will give us positive 14. So this is basically what I end up with for my f of x plus h once I have simplified. Now, what remains now is to take this f of x plus h, substitute into our first principles formula, and try to simplify and see what is going to happen when we do that. So let's go and see what will happen. If you continue here, the formula says f prime of x equals the limit, right, as h approaches 0 of f of x plus h minus f at x, everything divided by h. If you sub this, you will get the limit, right, as h approaches 0 of what? Let's see what will happen here. The f of x plus h, we already found it, so I'm going to rewrite this as minus 4x squared minus 8xh minus x minus h plus 14, which is quite cool. Now, this part, the f of x part, let's see what f of x is. I feel like it could have been much better again if we had simplified our f of x before we substitute it here, because it also has a couple of terms. So if you go back and look at it, this f of x here, we can try and make sense of what f of x is as a simplified expression or an equation in this case. Let's see what will happen there. We can just actually substitute it here, minus. In brackets, we've got negative, open bracket, that is basically, let's see what will happen there. It's actually minus 4x minus 7 and then x plus 2. 4x minus 7 and then x plus 2, okay. 4x minus 7 and then into x plus 2, right. And then everything must be divided by what? Everything must just be divided by h. Let's simplify and see what will happen there. This will be the limit as h approaches 0 of negative 4x squared minus 8xh minus x minus h plus 14. When you multiply the negative by negative, you will actually get positive. Open bracket, you've got, I'm going to start multiplying these brackets already. 4x squared will give me 4x squared there. 4 and 2 will give us 8x. And then we're going to have minus 7x, and then we're going to have minus 14 at the end. Everything needs to be divided by h. If you simplify further, what will happen? Well, you'll now have the limit as h approaches 0 of minus 4x squared minus 8xh minus x minus h plus 14. Now, these terms that you have here will basically be 4x squared. 8 minus 7 will give us 1x. And then you still have your minus 14 there. Everything divided by h. If you simplify further, you will notice that this is very important for you to keep in mind. Any term that comes from f of x needs to die once you get to this level here. If one of them survives, then it means you made a mistake somewhere in your simplification. So you will look at this and find that this one actually kills that one. They subtract each other off. Minus x subtracts x out, and 14 will subtract 14 out, leaving us with minus 8xh minus h all over h. Right. Now remember, the idea behind the first principles is just to remove the denominator, that h in the denominator there, because if you sub 0 by that h, you will have division by 0. It's going to be something that is indeterminate, and we can't actually work with those kinds of things. So we need to make sure that we simplify until we have deleted or removed by dividing out that denominator of h there. So if you look on the numerator that we have, you basically have the limit as h approaches 0. Common factor on the numerator is h, so I have h into minus 8x, and then minus 1, everything divided by h. If you simplify further, you will notice that h divides h out. You are basically left with limit as h approaches 0 of minus 8x minus 1. If you simplify this further, let's see now. We probably left a square in our h somewhere. Let's go back and see. There's your 4h squared. What happened to our 4h squared? All right, okay, fine. 4h squared, yeah, I feel like we left a term, that 4h squared here, we left it. We left this 4h squared here, which you can squeeze here, 4h squared. Let me use a yellow so that we don't actually confuse what happened with what's going to happen now. If you have that 4h squared somewhere, it's going to also appear right at the end there. You'll also have that 4h squared appearing there. Because we have already factored out 1h, you will have that 4h term remaining. And when you put your h as 0, you'll basically end up with the limit as h approaches 0 of negative. Okay, fine. We're now going to substitute our h as 0. So this part will be off when I substitute our h as 0. So we'll basically have negative 8x minus 1 plus 4 into 0 there, which will eventually leave us with minus 8x minus 1 as the final answer for the first principles question. So it's very important for you to understand that sometimes these questions get long. If they are long, try to make sure that you double check your work, take things bit by bit, step by step, don't make mistakes, and then everything will work out very well for you. Be careful with your multiplications and also count your terms and make sure that you're not leaving anything out, and everything else will work out quite cool. So we're now going to go to another question that will be taken by Philippa. Let's go check what the question says.
Hey guys, welcome, welcome, welcome. For those of you who've just tuned in, we're covering some first principles in calculus today. So I'm going to be helping you guys find the derivative. I'm going to jump straight into the next question sent in from one of our viewers. Let's see what they have to say.
Hi guys, my name is Sinso Mabasa and I am from Progress Comprehensive High School and we reside in Soweto, and we have a question for you. Shout out to my mom, my dad, and our maths god, Mr. Kekana. Thank you.
Alrighty, this is a really great question because there's a lot of potential for you guys to do the wrong thing with this question. I know immediately when some of you see this, those of you who do add maths, you think, chain rule. But remember guys, if you do add maths and you're writing a normal maths paper and you use add maths stuff in your paper, you're going to get it wrong. So don't use the chain rule with this. If you recognize that you need a chain rule in this application, then bravo, because you are remembering your add maths stuff, but don't use it in your maths paper. You will get it wrong. Okay. So let's have a look at this question because it's actually quite a long one and it's a bit of an ugly one. So let's just jump right into it. It says, determine dy dx, or just the first derivative, if y is equal to x squared minus 4x all cubed. Okay, so immediately guys, when you start dealing with things that have a power in them, you should automatically know that if you have this in the form of ax to the power of n, where a is any coefficient, by the power rule, the derivative, you take the exponent to the front, multiply it by the original function that you have, and then you subtract 1 from that exponent. But guys, because we have this operation here in the middle, that subtraction in the middle of that bracket, we cannot say that the derivative of this is equal to this. If we just applied this power rule here, we cannot just apply it because of that subtract sign there. Okay, guys? So before we even try to find the derivative, we need to multiply out this whole function so that we can differentiate afterwards. Okay, so I'm going to proceed with doing that. For me, I usually just take out one bracket and then I multiply it by the square of the other two brackets because it's all cubed. So that gives us x squared minus 4x, that first bracket that we took out, multiplied by x to the power of 4 minus 8x cubed plus 16x squared. Okay, so now we can further distribute. If we distribute that first term, we get x to the power of 6 minus 8x to the power of 5 plus 16x to the power of 4. Then we multiply out the second term, so we get minus 4x to the power of 5 plus 32x to the power of 4, and 4 multiplied by 16 is minus 64x to the power of 3. Okay, so now we can just simplify it by adding the like terms. So x to the 5, x to the 5, x to the 4, x to the 4. So now we can rewrite it. We have 1x to the power of 6, 8x to the power of 5 minus 4x to the power of 5 gives us negative 12x to the power of 5. 16x to the 4 plus 32x to the 4 is 48x to the 4. And then that last term at the end, that minus 64x cubed. Okay, so guys, now we've multiplied out that original function. Now we can start applying those simple power rules because we don't have any weird operations in that bracket that we were multiplying out. Okay, so let me remind you of that thing again. If we have the original function saying ax to the n, if we want to differentiate, we simply take the exponent that it was originally raised to, we multiply by the original function, and we subtract 1 from the exponent. Okay, so we need to do that to all these little individual terms here. Okay, so if we want to find y prime, the first term, we take the exponent to the front, x stays the same, and then we subtract 1 from the original exponent, so we get 5. Okay, for the second term, we're going to take the 5 to the front, multiplied by the original function, and then subtract 1 from the original exponent. Okay, now for the fourth term, or the third term, we do the same thing, take the exponent to the front, multiplied by the original function. Oh, look at me, I'm talking absolute nonsense here, guys. That would have multiplied out to be something completely wrong. Okay, let's do this again. Okay, so if we're looking at the second term here, we need to say 5 multiplied by the original coefficient multiplied by x raised to the power 4. You see, what I had done originally, guys, was I said 5 multiplied by 12x to the 4, which means that both the x and the 12 would have been raised to 4, which would have been incorrect. Okay, so make sure you don't make the same mistake that I did. Okay, so that's the second term there. If we move on to the third term, we say the exponent multiplied by the original coefficient multiplied by x raised to 1 less than the original exponent. And then that last term, take the exponent to the front, multiplied by 64, multiplied by x squared. Okay, so now all we need to do is multiply these out and simplify. So 6x to the 5 stayed the same. 5 multiplied by 12 is 60, x to the power of 4. 4 multiplied by 48, I'm going to use some mental maths here, so let me just do that on the side. 4 multiplied by 48, 4 times 8 is 32, carry the 3. 4 times 4 is 16, plus 3 is 19. Okay, so we get plus 192x cubed. And then this last one, 3 times 64, I'm also going to do some mental maths. I'll do it up here sneakily. 64 multiplied by 3. 3 times 4 is 12, carry the 1. 6 times 3 is 18, plus 1 is 19. Hey, check. 2 of the same exponents, or coefficients. Okay, so we get 192x squared. And that is the derivative. Hey, guys? So remember, if you look at this original function here, because of that subtract there and the fact that this whole thing is raised to the power 3, we cannot apply this rule immediately, guys. You need to remember that if you have a whole bracket raised to 1 power, if you have a subtract or a multiply or a plus or a divide in that bracket, you need to deal with the whole power first. You can't just apply the power rule when you differentiate. Okay, so remember, guys, that's really important. If you get this in an add maths paper, have at it with your chain rule, guys. I know it is so much simpler to use the chain rule, but here we're testing your ability to apply differentiation rules. So please, 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 guys, remember, brackets, you need to deal with that exponent first. Multiply it out. If it's to the power of 5, it's going to suck to multiply that out, but you need to do it before you differentiate. Okay, so thanks, guys. That was a really great question. Stay tuned for the rest of the show. We've got a lot of great more content coming your way, so stay tuned.